So when we talked about what statistics was, one of the things it entailed was gathering data. So we covered that in section 12.1, just talking generically about different ways to do that, sampling techniques. Then the next thing was organizing the data. And again, we did a real quick overview of that in the last section, talking about frequency distributions and some different types of graphs. And so then another thing that, that takes a lot of time in statistics is then analyzing the data. What are some attributes about it? What is this communicating to me? And being able to do that well. And so we are going to talk about what's called measure of central tendency today. And then we are going to talk just a real little bit about something called the normal distribution when we come back on Thursday. So a measure of center. So what we want to know is how can I measure where the center of any data set is? Because from the center, then you can see how the objects that you're measuring, how they relate to that central area. So a generic word that refers to the center of a group is called the average. And I mentioned this briefly when we talked about the misuses of statistics and using a word that has several meanings. We're going to talk today about 4 different averages. Okay. Now, you and me, more often than not, when we think of the word average, we think of a very specific thing, and that's where statistics gets misused. We're thinking something specific. The person who is saying it maybe is going to mean something different. So whenever you see the word average, when you're reading something online or in a paper or in a textbook, and it says the word average, that should be a red flag. Okay, because people should be more specific when they're talking to you about what average they are doing. So there are 4 measures of central tendency, just because I wanted you to write out the words. There are 4 measures of central tendency that we will consider in this class. And we're just going to go through and do some examples of each. And any questions that you have about this, please bring it up. So the first one's called the mean. Okay, and this is what we normally consider to be the average. And the way you calculate the mean, well, you tell me, because you've done this probably dozens and dozens of times. In this class, one of the things I'm going to do to calculate your grade, 60% of your grade is the mean of your tests. So what am I going to do to calculate your mean of your tests? I'm going to add up all the tests and divide by how many tests there are. In this case, since I'm going to drop one, I'm going to count 5 of them. That's how I'm going to calculate your mean. So to find the mean, what you're going to do is you're going to add up all the values and then divide by how many values there are. So that's a lot to write every time. And of course, you know, I've told you before, math people are fundamentally lazy about math, so they like to use symbols and everything. So the symbol that we're going to use, we're dealing with samples in here, which means just a small subset of our population. So the symbol for the mean we're going to use is X with a bar over it. Okay, that's going to represent the mean. And then the notation to indicate that you're finding the mean is this. This might be a new symbol for you, but that's fun. You get to expand your learning a little bit. This is a capital Greek letter called sigma. Looks like an M that's on its side. So that's called sigma. And so I'm going to put an X by that. And I'm going to write over here on the side, just in case you've never seen sigma in terms of math. The sigma means to add up, or it means the sum. So it's just a shorthand lingo for add up all the values. That's what that says mathematically. Told you math people are lazy. They don't even want to write words. They just want to write symbols. Okay, so this says the sum of all your values, the sum of the x's, and then I'm going to divide by, and in the bottom, I'm going to put the letter n for the number of values there are. So I've just written symbolically the same thing I wrote in words right above. Okay, so from now on, I'll use the symbolic version of it just because I'm a math person, so I'm fundamentally lazy as well. So here we go. My first example, I'm going to go ahead and do this. I probably don't even need to do this example, but I feel like being a good professor means being thorough. So what we're going to do is determine the mean age of a group of firefighters if the ages of the individuals are given by these values: 30, 21, 51, 37, 51. Okay, so the mean, I'm going to write this out. You don't have to write this out like this every time, but I'm doing this for your notes. The mean is this. It's the sigma x. It's the sum of the values. So it's 30 plus 21 plus 51 plus 37 plus 51. How many values are there? 5. There we go. And now I'm going to come over here. And then the convention, again, always follow my math lab's directions. I don't know how many science classes you've had, but the convention is you can always round to one more decimal place than your data has. Okay, that's kind of how rounding goes. So since my data has no decimals, my answer will have one decimal place in it. So we got 30 plus 21. Just popping this into my calculator. I know it's exciting to watch me do that. And then I'm going to divide that by 5. And hopefully everybody got the mean is 38. Now, just because the numbers are smaller, after you do example 2, I'm going to show you what the mean is measuring, what center it is actually measuring, just because those numbers are going to be smaller and it's easier to draw a little picture. So please do example 2 and find the mean of those values. All right, so the mean is this. I'm going to add up all the values. So I've got 4 plus 6 plus 7 plus 7 plus another 7 plus 9 plus 9. My pen is just about out of ink, but we're going to see if it can make it through the end of this problem. And so then how many values do I have? 7. And again, if there's going to be a decimal here, we'll round to one decimal place. And what do we get when we do the mean? Just 7 right on the nose? Okay, fantastic. Well, I've changed my mind. I'm going to draw the picture for the firefighters. So here's what the mean is. Here's what the mean is doing. So what I'm going to do is I'm going to draw a line right here. This represents my mean, okay, of 38. Okay, that I'm just going to say down here, that's my mean. And so what the mean is measuring, what the center is there's going to be just as much distance of my values below the mean as there is distance above. And here's what I mean by that. The first firefighter's age was 30. So I've got this value 30. How far below the mean is 30? 8 below. So I'm going to put a -8 right there. Okay, everybody tracking with me what I'm doing? Okay, then 21, got a real young firefighter. So that firefighter's way out here. How far below the mean is that firefighter right there? Yeah, 17 below. So I'm going to go -17. The next firefighter is 51. So we're now out here. How far above the mean is that firefighter? 13. So I'm going to put a plus just to reinforce that that's positive. The next one's 37. So just right here, and that's -1. And then finally, we've got another one that's 51. And so that is plus 13. So what the mean is, this is how the mean measures the center. This value right here that we found, the mean, is the value that cuts the data so that there's just as much distance below. -8 and -17 is -25, and -1 is -26. So there's just as much distance below as there is distance above. 13 and 13 is 26. So the mean takes into account the spread out nature of the data. Okay, so that's that. When you measure the mean, that's how you're measuring the center right there. You're measuring according to how much distance there is between the values and this central data. Not all the measures of center. In fact, none of the other ones measure the center that way. All right, I would like you to do example 3. Find the mean of that string of values. Okay, so this one, the mean, is going to be the sum. I'm going to write this out symbolically instead of writing out all the values this time. So it's the sum of the values divided by n. And so my sum of the values, well, what did you get? You guys have already done this. What do you get when you add up all those numbers right there? 92? Do I have confirmation of that? That sounds good. I'm not hearing anybody object, so I'm going to go with the 92. And then how many values are there? 14. Okay, again, if this is going to turn out to be a decimal, since all my data was whole numbers, I'm allowed 1 decimal place. So 92 divided by 14 is 6.57 and a whole bunch of other things. So we're going to round that to 6.6 is going to be the mean. Okay. You're allowed 1 more decimal place than your data has. Just to make sure that I'm doing a good job and everybody's feeling nice and confident when you leave here today, there's one more example of the mean. So please do example 4. Bless you. Wow. It's amazing. All right, so we're going to find the mean again. So first thing we got to do is got to add up all those values. So what do we get when we add up those values? What's the total? 622. Did I hear that right? Okay, and I think I heard confirmation. And then how many values are there? 10. Oh, that's nice. I can divide that without the calculator. So 622 divided by 10, we're allowed 1 more decimal place. So if you did use your calculator, it's 62.2. Again, each of these values we found is the mean, 62.2. What that means is there is just as much distance below on my values as there's above. And notice one of the things that it's not really a problem, but one of the things that the mean is susceptible to is we've got this 385. 385 is significantly different than any of the other values. And so what happens is that 385, it skews the mean in that direction because 385 is so much different than everything else. So that means, look, you have your 62.2. Every value except 1 is below the mean. And so sometimes, now we're not going to talk about it in this class, but if you take statistics, what you'll talk about is what's called a trimmed mean. In order to avoid that, okay, what you do is sometimes you might say, I'm going to have a 10% trimmed mean, meaning I'm going to cut off the bottom 10% of values. I'm going to cut off the top 10% of values, hopefully to get rid of any outlying values like that. So you get a better picture of what the true center of something is. So the mean is susceptible to when you have a significantly different value. Okay, something a little bit different. I am going to ask you to do something like this on the test. So if you have a question, this would be a great question. Is example 5. Now, I'm going to give you 30 or 45 seconds to see if you can make heads or tails of this. And so I'm going to give you a little hint. Here's the formula for the mean. It says that the mean, okay, that's the mean value, is equal to the sum of the values divided by n. There's 3 things that we have right there. And so in example 5, it says that Malcolm's mean on 5 exams is 81. Can you figure out what the sum is? Okay, so there's a couple ways you could go about this, but I'm going to use that formula in just a minute. So I've given you in that problem 2 of the 3 things you need to figure out Malcolm's total. See if you can do that. By the way, if you can't, it's okay. Doesn't mean there's anything wrong with you. Just means that this is a difficult problem. Okay, so I referred you just because I don't want you struggling in case you are too much, because once you see it, it's probably not that big of a deal, but to figure it out, it might be. So I'm just going to, again, direct your attention to what is the symbolism for the mean. Well, the mean, x bar, is equal to the sum of the values divided by how many values there are. And I've given you 2 of the 3 things. What have I told you is the mean in this problem? 81. So I'm going to write down 81 is equal to. The sum is the thing that I'm looking for right there. So I'm going to just leave the sigma x right there. And then how many values have I told you there are? 5. Great. So I've just got 1 step now to figure out what the sum is. What do I have to do with this 5 to both sides of this problem? Yeah, I've just got to multiply. I've got to multiply the 81 by the 5. Cross multiply. Perfect. And so that's going to tell me then 5 times 81 is, I think, 405. That is equal to the sum of the scores right there. So example 6 is a little bit different, but it's kind of the same general theme. It says, and this might be something that you need to do as you're figuring out what you need to get on this 6th test in order to maybe get in a certain range for yourself. A mean of 80 or more on 5 exams is needed for a final grade of a B in a course. Sarah's first 4 exam grades are a 73, a 69, an 85, and an 80. What grade does Sarah need on the 5th exam to get a B? Okay, so this is similar in makeup to the last problem. I'm gonna walk you through this one a little bit. So again, we're gonna start off with this statement that the mean is equal to the sum of the values. That's a terrible sigma. Sorry about that. My pen got caught. It's like a sigma that was in a car accident. Needs a chiropractor. So my mean is the sum of the values divided by n. So again, you're going to help me. What's the mean we're looking for? Okay, 80. Sarah wants to get an 80. She wants to get a B in this class. Great. Now here's where we got to be careful. There are 5 tests. So we need the sum of the values. So tell me some values of the test that we have right here. How many tests is that? 4. Sarah wants to know what she needs on the 5th test. Does she know? No. So what do we need to call that 5th test? I'm not. You can use any letter. I'm just going to avoid N because that's the letter we use in the bottom. Okay, so but any other letter you want, it really does not matter. I'm partial to X, but any letter you want to put right there, or a smiley face or a question mark, just a box, just something to indicate we don't know what that 5th test is. In the bottom, I've got 5 because there's 5 values. All right, well, again, there's not a lot of algebra that's required for this class. A couple different occasions, we've had equations to solve. So this is just an equation to solve. What do I do first here? Anybody know what I do first? I'm sorry, what'd you said? Sure, we can add up those values. That sounds great to me. So 80 is going to be equal to, when I add up 73 and 69 and 85 and 80, what does that add up to? 307? What should I do next? I'm sorry? I'm not going to divide because I would have to divide the 5 into both of these things. You have to distribute, and that's going to be hard to do since I don't know what the x is. But I do want to do something with the 5. Yeah, like we did in the previous problem, I'm going to multiply both sides by the 5. So 80 times 5 gives me, that tells me the total number of points. And now I have one more thing to do, and we can tell Sarah what she needs to get on this last test to make her B. And what is that last thing I need to do? Perfection. Great job. So that means X, or whatever letter you used, or box, or whatever symbol for the unknown item you used, that last test has to be equal to 93. She needs to get 93 on that. Now yours is like when you go to calculate your final grade, I can show you after class if you want. Yours is a little more complicated because we do some percents, but it's still something you can set up like that if you want. Okay, that's the mean. I'm done talking about the mean. Does anybody have a question before we move on to the next measure of center? All right, well, don't be shy, okay, please. We've got plenty of time. The median is the next one. Now, the median measures the center of your data in a different way. The symbol we're going to use in here for the median is X with a squiggly over it. Okay, so X with a squiggly is our median. And what the median is it's the physical center of an ordered, I'm going to underline that because that's important, an ordered set of data. Basically, what the median says is what value is in the middle. So the thing about the median, it is measuring the physical center. It actually does not take into account any of the values at all. And so another way to think about the median is this. Half the values are above. And half the values are below the median. In news articles, one of the common places you see the word median is when they are reporting household incomes in a particular area. They will say something to the effect of the median income in a certain area is X number of dollars. And so that what that tells you is whatever value that is, half the people in that area make above that, half the people in that area make below it. The median divides your data right in half. All right, so I'm going to do these first 2 examples because I want to show you what to do for your sample when you have an odd number of values and we have an even number of values, how you find the median in each one. So example 7, this is based on my firefighters. So we're going to determine the median age of a group of firefighters if the ages of the individuals are 30, 21, 51, 37, 51, same ages before. So first thing you have to do when you calculate the median is you have to order the data. So I'm going to list it out from lowest to highest. So the smallest value is 21, and then 30, and 37, and then 51, and 51. All right, so I have an odd number of values. I got 5 values right here. Which value would have the same number of data points above it and below it? Yeah, so when you have an odd number of data points, The median is actually one of the data points. So in this case, the median is going to be 37 because I've got the same number of values above the number 37 as I have below the 37. So the median, X with the squiggly, is equal to 37. That's the median age of those firefighters. We're going to redo that problem in example 8, and I'm going to say, okay, if a new firefighter age 28 is added to the group, what's the median now? Okay, fantastic. So let's list out our values. So now I've got 21 and the new person 28, and then 30, and then 37, and then 51 and 51. Now I have 6 firefighters. So now I'll tell you how to find the value in a minute, but now it's not going to be a value in the data set. It's going to be a position. Between what values would I have the same number of data points above and below? Yes. So this time the median is going to be between those two values. So when you have an even number of data points, here's what you do. You take those two closest values, the 30 and the 37, and you just find the midpoint. So the median, the X with the squiggly, is going to be 30 plus 37 divided by 2. Okay, so I'm just finding the midpoint between 30 and 37. And when I do that, that's 67 divided by 2, and that is going to be 33.5. So after you list out your values, you have a decision. If you have an odd number of values, your median is the central one. If you have an even number of values, your median is the center between the central point that has the same number of values above and below. So try example 9. Find the median, please. All right, the good news about this problem is I already ordered the data for you on it, so it makes life a little bit easier. So how many values do I have? 1, 2, 3, 4, 5, 6, 7. So since I have 7 values, that means that my median is going to be the one that has 3 on each side, and then the 7th one is going to be the central value. And so that is going to be, it doesn't really matter which one, but that's going to be that 7 right there that has the arrow. So the squiggly, the median is 7. There are 3 values above that central value. There's 3 values below that central value. Again, the median doesn't care what the values are, doesn't care how spread out the values are. It doesn't care if there's an outlier. The median is just the physical center of the data set. And that's why it's commonly used, because it gives you that 50-50 picture of what a sample or a population looks like. Do example 10, just now we're getting a little bit of practice. Okay, again, I've ordered the data for you. That makes this take a little less time. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 14 values. So that means I'm going to have 7 on each side. So 1, 2, 3, 4, 5, 6, 7. So I'm going to cut that right there. So I have 7 values on each side. The median is the midpoint. Well, it's the same value. Okay, but if you went ahead and did what I said previously, I'm just going to do it just in case you did. That's 4 plus 4 divided by 2, which is 8 divided by 2, which is 4, because those are just the same value. So the median is 4. We doing all right? All right, one more median problem. This time I haven't ordered because you get to do a little extra work on this one. You're welcome. All right, so first step, I put all the data in order. There, you see it right there. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So that means there's going to be 5 on each side of the median. So 1, 2, 3, 4, 5. So I'll cut right there. Those are different values this time. So my median, my X with the squiggly, is going to be 21 plus 22 divided by 2, which is 21.5 is the median that time. All right, before I move forward from the median, we still okay? Okay. See a smile. That's great. Confidence. I love it. Okay, so here's the second to last measure of center. In fact, we already mentioned this word today when we were talking about looking at the graphs, the mode. The mode is the most frequent frequently occurring value. The symbol for the mode that we're going to use is a capital M. So I have 3 examples because I want to show you one of each situation that might happen. Okay, so that you've seen everything that can possibly happen with the mode and there's no mysteries. So the first thing, example 12, determine the modal age of a group of firefighters if the ages, we're going back to the original set. We've got the 30, the 21, the 51, the 37, the 51. In that set of values, is there a value that occurs most? 51. Okay, 51 is repeated. It happens twice. And so that is going to be the modal value. Okay, most of the time, the mode is very straightforward. It is just the value that occurs more than every other. Okay. Example 13, I'm going to say this. If one of the firefighters in the last example, age 51, retires, what's the mode? Okay, so I'm going to list out the set now. One of the 51-year-olds retires. So we've got now what's left is 31, 21, 51, and 37. In that set of data, is there a value that occurs most? No. Okay, they're all just happen one time. So what we write here is that there is no mode. It is not, okay, please do not write the mode equals 0. That is different. 0 is a value. If you write, okay, so if you write that the mode equals 0, then what you're saying is the value 0 occurs more times than anything else. There's no value 0 over here. So that's why that's wrong. So please do not write mode equals 0. It's no mode. Lastly, going back to example 12, if another firefighter age 21 is hired, what's the mode? Okay, so going back to my original, so we've got a new 21-year-old, and we're adding that on to the 30, the 21, the 51, the 37, and the 51. Okay, is there a value that occurs more than every other value? There's 2 values this time, okay? Now, this doesn't, well, this will happen in your example. I'm not going to mention it. So what happens if you have 2 values that occur the same amount of times, okay? So we've got 2 21s and we've got 2 51s. So we've got 2 values that occur the same most number of times. What you have here is what's called a bimodal set of data, and the mode is equal to 21, and then I'm going to write a comma, and 51. There's 2 modes to that. You don't have to write bimodal. I'm just writing that for you so you know what it is. What you do have to write is that the mode is equal to, and then you got to give me the 2 values. All right, so I've got 3 examples for you on the next page. I'm going to give you like a minute or minute and a half. Go ahead and do all 3 examples. Find the mode for me for all of them. Okay, so our modes. Let's see how you did. So example 15, I've got 4, 6, 7, 7, 7, 9, 9. Does a value occur more than the others? 7. Now, sometimes students will say, hey, is this one bimodal because 9 repeats too? Remember, mode means most, okay? So even if something else repeats, if it's not the most, so 7 happens 3 times, 9 only happens 2, so 9 is not a mode, okay? You with me on that? Okay, so I just want to try to avoid any confusion. Example 16, is there a value that occurs more than all the others? Yeah, 1 and 4, so we have 4 1s, we have 4 4s, nothing else repeats 4 times, so this is bimodal, 1 and 4, great. And then lastly, example 17. Is there a value that happens more than anything else in this one? No, nothing repeats, so this is no mode. Excellent. Yeah. Okay, 9 would not be a mode because 7 happens 3 times. 9 only happens twice. So mode means most. And so since 7 happens most, it's only that one. Now, if you would be right if there were 3 9s, okay, if they happen the same number of times, that's when you have something that has 2 modes. Okay. Good to be clear on these things. Awesome. Because I'm going to make that distinction on the test when you take it, just to make sure that you're awake. All right, last one. And then we're done with our measures of center. The mid-range. Now, the mid-range is kind of the lazy way to calculate the middle of your values when you don't have time or you just want to get an approximation. The mid-range only considers the high and the low values. It ignores everything else in the thing. So the mid-range is the center between the high and low values. So the mid-range is not really useful if you have data that's really spread out or if you've got an outlying value. But again, it's good in a pinch when you need something quick. So the mid-range, I'm going to abbreviate MID. It doesn't get a symbol. The mid-range is the high value, I'm just abbreviating, plus the low value divided by 2. That's all it is. So again, I probably don't need to do an example, but I'm going to just to be thorough. I'm going to do example 18 one more time, our firefighters. So we've got our 5 firefighters. What's the mid-range of the values? Well, the mid-range here is the age of the oldest firefighter, which is 51. Plus the age of the youngest firefighter, which is 21, and then we'll divide that by 2. And when you pop that into your calculator, that's 72 divided by 2, and 72 divided by 2, I believe, is 36. So that would be the mid-range. All right, so again, I'm going to give you about 90 seconds. You got 3 examples to calculate the mid-range of, if you would please do that. All right, so example 19, the mid-range, the high value is 9, the low value is 4 divided by 2, so 13 divided by 2, you should be looking at 6.5. Anybody get something different that we need to talk about? Okay, so again, all the mid-range does is takes into account the high and the low value. Everything else, whether values are repeated, anything is totally ignored by the mid-range. The mid-range of the next one, the high value of the next data set is 21. The low value is 1 divided by 2. So that's 22 divided by 2, or 11. And then last but not least, the mid-range of the final one is 385 plus the low value turns out to be 14. That is what, 399 divided by 2, and that turns out to be what? Thank you for your help. I appreciate that, 199.5. Are there any questions?